Okay, so this is the 7.5 practice set from the CK12 geometry text. So we're going to use the diagram to fill in the blanks below. Number 1, tangent of D equals the opposite leg over the adjacent leg, which would be little d over little f. Sine of f is the opposite leg over the hypotenuse, which would be little f over little e. Tangent of f would be opposite over adjacent, which is f over d. Cosine is the adjacent leg over the hypotenuse, so cosine f would be d over little e. Sine of d would be d over little e, and cosine d is f over e. All right, the next part, find the sine, cosine, tangent of angle A, reduce all fraction and radicals. So I've got all three sides for number 14. So the sine of A would be the opposite leg over the hypotenuse, which would be 16 over 20, which reduces to 4/5. Cosine of A is the adjacent leg over the hypotenuse, which would be 12 divided by 20, which simplifies to 3/5. And tangent of A is the opposite leg over the adjacent leg. So that would be 16 over 12, which simplifies to 4/3. In number 15, we end up getting a 45, 45, 90 isosceles right triangle. So that means both my legs will be 4. This is a special triangle. So my hypotenuse will be 4√2. So sine of the angle A is 4 divided by 4√2, which simplifies to 1 over √2, or √2 divided by 2 if we rationalize the denominator. Cosine of A will end up being the same. This is going to be true for any right isosceles triangle. Now the tangent of A is going to be 4 over 4, which is 1. And the tangent will always be the same for 45, 45, 90, and that's 1. On number 16, we first have to find the leg. So we know 9 is one leg and 27 is the hypotenuse, so I can use Pythagorean theorem to find the unknown leg. So when I do that, and we've done this before, so this should be some practice, I have to simplify this in radical form. 648 simplifies to 4 times 162, which is 4 times 81 times 2, and that simplifies to 18√2. So now sine of A would be the opposite over hypotenuse. 9 over 27 is 1/3. The cosine of A would be the adjacent over the hypotenuse, which would be 18√2 over 27, which is 2√2 over 3. And tangent of A would be 9 divided by 18√2. And we have to simplify and rationalize the denominator, and this gives us √2 divided by 4. Find the length of the missing sides. Round your answer to the nearest hundredth. So the x is the opposite leg, y is the hypotenuse, and 15 is the adjacent leg. So I know SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So let's use the cosine of A equals adjacent over hypotenuse. Cosine 32 equals 15 over y. I need to solve for y, so I can multiply it to both sides, divide by cosine 32. Now I have to be really careful when we put this in our calculator. We need to make sure that we're in degrees, not radians. So double check your calculator. 17.69 is our answer. To find x, we can use tangent, which is the opposite over adjacent. So tan 32 equals x over 15. I can multiply both sides by 15, and I get 9.37. So we're going to do, for number 18, we're looking for both the legs and the hypotenuse is known. So in this, we're going to use sine and cosine for both of these. To find y, I can use the sine function, and to find x, I can use the cosine function. We could also use Pythagorean theorem once we have 2 out of the 3 sides, but since we're rounding here, we don't have an exact value, so we should use the given values. Number 19, we're starting to get in a rhythm here. We're going to use sine to find y, and we're going to use the tangent function to get x. And we get our values for x and y. Notice here I'm putting red as the sine equations, and blue, cosine, and green are the tangent, color coding it for you. So these last few, you should be getting the idea here. So I think I'll just speed up this last part. Okay, so let's look at some problems here. The angle of depression from the top of an apartment building to the base of the fountain in a nearby park is 72 degrees. If the building is 78 feet tall, how far away is the fountain? So I've made this sketch, and I've shown the horizon and the angle of depression to the base, and we could see that we know the height. Basically, we can use tangent to find that distance from the base of the 2 buildings. And when I solve for x, I get a distance of 25.3 feet. So the fountain is 25.3 feet from the apartment building. In 24, I've got 2 buildings that are 100 meters apart. The angle of elevation from the corner of the small building is 47 degrees. The height of the tall building is 120. How tall is the short building? Well, I know I have a rectangle here in between the 2 buildings, so the opposite sides will be equal. So if I can just find the extra bit of height, y, that I've labeled here, I could subtract that from 120 to figure out what x is, which would be the height of the apartment building. So by using tangent again, I can find y is 107.2 meters, subtract that from 120, and I get 12.8 meters. So the shorter building is 12.8 meters tall. 28, William spots a tree directly across a river from where he's standing. Then he walks 20 feet upstream and determines the angle between his previous position is 65 degrees. So I can set up a right triangle, and I know that 20 feet will be one side, x is another unknown side, and my angle is 65 degrees. So again, we use tangent. Tangent is the most useful in most of our practical problems, and I get 42.9 feet wide. The United Nations disaster relief plane is approaching a village that's devastated by flood. It's traveling at an altitude of 6,500 feet at a speed of 140 miles per hour. The village is at a 10-degree angle of depression. So I can set up my problem and find the distance, the horizontal distance from the plane to the village. And if I know the distance, I can find the time if I have the speed. So again, we use tangent. I use 10 as my angle, and I use 6,500 feet as my opposite side, and d is my adjacent side. So my distance is 36,863 feet. Let's convert this into miles, because we've got miles per hour, which is our rate. So if we put the distance in miles, then we have a consistent unit. So I'm going to multiply by the unit conversion, 1 mile divided by 5280 feet, and it's about 7 miles. So how many minutes will this plane be over the village? If it's traveling at 140 miles per hour and the distance is 7 miles, well, distance equals rate times time. Substitute my knowns, 7 miles and 140 miles per hour, and divide both sides by 140 to solve for t. 7 divided by 140 is a small number. Well, it doesn't take very long traveling at this speed, 0.05 hours. There are 60 minutes in 1 hour, so why don't we go ahead and multiply this times the unit conversion, and we will get 3 minutes. So it's only going to take 3 minutes for the plane to drop the supplies on the village. Okay, we're done. I hope that was useful.